Updating the metric of transportation impact. Problems with LOS. Virtually everyone has been behind the wheel of an automobile and found themselves traveling the same route as enough others driving automobiles that you together congested the road, slowing you down and annoying you. So it's understandable that the transportation profession came to use metrics of auto delay to define success in transportation and to guide improvement. The problem is, in doing so, we have defined this as complete success, even though there's not much of anywhere to go, and this as abject failure, even though there are plenty of places you can get to just within a few steps. This hypothetical example distinguishes auto delay's portrayal of success from actual success in transportation. Given the choice between commute A and commute B, LOS would choose commute A because there's less delay. But most people would choose commute B because you arrive sooner. How quickly and easily you can get to a place is called accessibility, or access to destinations, or connectivity. These terms are interchangeable. While accessibility describes transportation outcomes directly, metrics of auto delay, such as LOS, often provide questionable verdicts on success or failure. Here's some real-world data. Denver, over this 25-year period, built a lot of infill development. That added congestion, leading to an increase in rush hour delay of about 2.5 times. So Denver's approach appeared to be terrible for transportation through the lens of auto delay. But average travel times went down. Metrics of delay can get success or failure in transportation backwards. Here's a comparison between two cities. Chicago's average commute is 13.5 miles and takes 32.6 minutes, including 9.8 minutes of delay, while Charlotte's is 19 miles and takes 48 minutes, including 9.6 minutes of delay. From a delay perspective, Charlotte's average commute is better, even though it takes far longer. This study examined the relative effects of proximity and of speed on accessibility. The vertical axis on each scatter plot shows job accessibility, the number of jobs that can be reached. The left graph shows how the number of jobs nearby affects the number of jobs that can be reached. Unsurprisingly, the greater number of jobs nearby, the more jobs are reachable. The right graph shows how vehicle speeds affect the number of jobs that can be reached. We might expect that the faster one could drive on nearby roads, the more jobs one could get to, but observing the data, we see that where average travel speeds in the neighborhood are faster, fewer jobs can be reached. It turns out, in order to keep traffic moving quickly, development must be spread further out, and the spreading worsens accessibility more than keeping speeds up helps. That study examined the greater Los Angeles area. It was repeated in the San Francisco Bay Area with similar findings. The study authors wrote, quote, "Myopic focus on the traffic impacts of new developments, which is precisely the use of LOS as a measure of transportation impact, is misguided and may actually decrease accessibility and economic activity in an effort to protect traffic flows. So, our state's shift away from LOS will benefit not only environment and human health, but also people's ability to get places, and thereby also the economy." In California, several laws and policies direct us to prioritize infill development over sprawl. Let's compare how LOS works for infill to how it works for outlying development. An infill housing project loads relatively little vehicle travel onto the roads because residents can often bike, walk, or take transit. And when they do get in a car, trips tend to be shorter due to the centralized location. But nevertheless, infill tends to trigger numerous LOS impacts because existing development has often filled nearby roads to near the LOS threshold, leaving that last in infill project to trigger the threshold and take responsibility for fixing it. This pins the cost of fixing LOS on infill. Mitigation funds are then spent adding auto lanes and other fixes that allow people to drive through the neighborhood more easily, but often worsen conditions for biking and walking and worsen livability in the neighborhood. We compare that to a greenfield project at the urban periphery, which generally loads 3 or 4 times the vehicle travel onto our roads, yet tends to trigger relatively few LOS impacts. The greater amount of vehicle travel loaded onto the roads often becomes dispersed enough by the time it reaches congested areas that it doesn't trigger LOS thresholds at any one place, even as it contributes broadly and much more substantially to regional congestion. Ultimately, and ironically, LOS creates poor outcomes for transportation. Holding development responsible for fixing LOS leads to more sprawl and more people choosing to travel by car, both of which, ironically, worsen congestion. Fixing LOS often simply moves a bottleneck downstream. Not infrequently, the bottleneck moves to a more critical intersection and congestion is worsened overall rather than improved. That phenomenon is known to traffic engineers as Bray's paradox. More spread out development patterns force people into taking longer trips, undermining accessibility and access to opportunity for everyone, but particularly those with limited access to an automobile. Also, LOS assessments are time-consuming, expensive, and inaccurate. For a large project, an assessment can take months and add millions of dollars to project costs. And delay is often reported to multiple decimal places, concealing the uncertainty inherent in the analysis. Traffic volumes that will be arriving at an intersection are often known to plus or minus a third or so, which can translate into a letter grade or two of error in LOS. LOS also creates poor outcomes for communities. It inhibits infill in vibrant locations, sending development to the urban periphery. It values a transit rider's time at a fraction of a car driver's, seeing cycling and walking as impediments to transportation rather than as transportation. And it blocks transit, bike, and pedestrian projects. It requires adding pavement, which exacerbates the heat island effect, taxes public works maintenance budgets, and increases impermeable surfaces. It leads to poor outcomes for the environment, including impacts from additional driving, such as emissions, and impacts from far-flung development, such as higher building energy use and water use, greater acreage of impermeable surfaces, which exacerbates flooding and increases pollutant transport into waterways, and consumption of agricultural land and sensitive habitat. And it leads to poor outcomes for human health, as more driving means less biking and walking and more crashes. If you would like to have a look at the full studies and reports underlying what we shared in these slides, or would like more information on problems with using metrics of auto delay such as LOS, please visit the Key Resources section of the SB 743 page on OPR's website.